Hello and welcome to Module A4, to the first of two videos, and we're going to take you through how to do trial and improvement. We've got some examples to go through, and on the video 2 you can have a go at some yourself. You're going to need your homework book, but also you're going to need your calculator, and we need to be able to do this on the calculator. Okay, so we'll have something like 5.5 squared. How do we do that? Well, the key we're going to use is this important one there with a red circle, that little x squared. And so what we do is press 5.5, then we press that key, and then we press equals. Try it, and you should get 30.25. Now, as well as the squared, we could also use cubed. So we can have a go here at 4.2 cubed. So we're going to press 4.2, then there's an x cubed key, and that is just up there, look, little red circle around it. So try that, and you should get 74.088. Good. So now let's have a little exercise just to make sure we know what we're doing. So try and work those out on the calculator. Press pause, press play for the answers. Okay, so we did 3.7 squared, that should be that. 13.69, 0.42 squared is 0.1764. And then 2.9 cubed, 24.389, 0.3 cubed, 0.027. Good. So let's get going and have a look at a kind of question we could have. So the question gives us an equation, x squared minus 5x minus 3 equals 0. And it tells us there's a solution between 5 and 6. And it says use trial and improvement to find the solution correct to one decimal place. So quite a few important things there. Between 5 and 6 is important, and one decimal place is also important. Now what we're going to do is set up a little table like that. We're going to try different numbers for x in that equation using our calculator, and then the result is whether we're above 0 or below 0, because we're trying to get 0 as the answer, because it says at the top x squared minus 5x minus 3 equals 0. So let's have a look. Now that's the first important bit. A solution lies between 5 and 6. So we know the solution is between 5 and 6. So let's take the number in between 5 and 6, which is 5.5. So that goes in our table then as the first x. Now on the calculator, you're going to press 5.5, then the x squared key, then minus 5 times 5.5, and then minus 3. Okay, we're just following that equation, and remember, we're trying to get 0. Now, if you put 5.5 into that equation on your calculator, you'll get minus 0.25. Now, that is below 0, or we say the result is low. It's lower than what we want to get. So that means we're going to have to increase our x. Now, we're not going to go mad and try 5.8 or 5.9 or something. We're just going to go up by 0.1. So we're going to try the next number, okay, 5.6. So you put that into the equation, and you get an answer of 0.36. Now that is above 0. In other words, it's high. And this is the situation we want to try and get. And in future, they won't be quite as quick as this, but we've got two numbers for x, 5.5 and 5.6. They're next to each other on a number line, and one is low and one is high. So what we've got to do now, we're going to try 5.55. So that's the number in between 5.5 and 5.6. And the reason is 5.5 is too low, 5.6 is too high, so the solution must be in between them. So let's try 5.55 in that equation, and we get an answer of 0.0525. Now that's above 0, so in other words we say the result is high. Now that's all the calculator work, and we get most of the marks really for the question for that, but this is the tricky bit. This is where everyone kind of gets a bit confused. So now the solution is between 5.5 and 5.55. I've grayed out 5.6 there. So if we had a number line like that, okay, 5.45, 5.5, 5.55, etc. Now we know our number is in between there. It's in between 5.5 and 5.55. Now in the original question, notice up there, it says we want the answer to one decimal place. Now every number covered by that green arrow, if you round it to one decimal place, is actually 5.5. We don't go up to 5.55, we go just before it. So all the numbers in that little gap, which I've got a green arrow in, are equal to 5.5 to 1 decimal place. So that is our answer. Now that's a bit confusing. So let's have a look at perhaps a slightly different way of explaining it. There's our number line. Now we did 5.5, that was too low. We did 5.6, that was too high. So we tried 5.55. Now when we did that, our answer was high. So we know our answer must be in between a number that gave us an answer that was too low and a number that gave us an answer that was too high. So it's in that gap there. And all we say is, well, everything in that gap between 5.5 and up to, but not including 5.55, if you round it to 1 decimal place, is 5.5. Okay, that's the tricky bit. You might not be perfect on that at the moment. Let's see how it is after a couple of examples. Now all that arrowy stuff and number line at the bottom, we don't need to write. That's what you would write in an exam. Let's have a look at another one and try and sort things out. Solution to the equation x cubed equals 35 lies between 3 and 4. So it lies between 3 and 4. We're going to try 3.5. Nice simple equation this time. It's just 3.5 x cubed. Now the answer is 42.875 there. But we are trying to get 35. So that is too high. So we've got to go down. Now we're not going to jump down loads. We're just going to jump down to the next number, 3.4. Try that in the calculator. 3.4 x cubed, and that gives us 39.304. Remember, we're trying to get a solution to the equation x cubed equals 35, so that is too high. Now we're not going to jump down to 3.2 or anything, we're going in nice easy steps, 3.3. That gives us 35.937, still too high. Let's try 3.2, and that gives us 32.768. Good, we got one too low. So now we've got neighbouring numbers, 3.3, 3.2, one's too high, one's too low. So we know our solution is in between them. We don't know which one it is, if it's 3.2 or 3.3, but we know it lies in between them. So let's get this little graphic up there. 3.2 was too low, 3.3 was too high. So we've got to go in between. So that will be 3.25. Okay, let's try 3.25 on our calculator. 3.25 cubed is 34 point blah blah blah. In other words, too low. So let's write low there. So we know that the solution is between one that gives us an answer that's too low and one that gives us an answer that's too high. So it's in between there. But if you take every number in between 3.25 and 3.3 to 1 decimal place, the answer is 3.3. Now lots of people remember this as you get your number 3.2 and 3.3, one too low, one too high. You try then in the middle, 3.25. If the middle is too low, we go up, and if the number in the middle was too high, then we go down. That's one way of thinking of it. And once again, what you would write in the exam is just that. Okay, let's have a look at a couple more. So another x cubed, and the solution in the question, it says the solution to the equation lies between 6 and 7. That's why we've got 6.5. So let's try 6.5 cubed minus 6.5 minus 300. That gives us minus 31.875. We're trying to get 0, so that's too low. So we've got to go up with our x now. Let's try 6.6. So that gives us another number that's too low, but we're not panicking, we're not taking big jumps, we're just going up now to 6.7. Now we try 6.7 cubed minus 6.7 minus 300. We're still getting the minus number, so it's still too low. So let's go up again. No big jumps, just nice and easy, 6.8. And there we've got a number 7.632, which is too high. And that's great. We've got what we want now. We've got 6.7 too low, 6.8 is too high. So let's illustrate that on our number line. 6.7, too low, 6.8 is too high. So what do? We know the answer's in between them. So let's try the number right in the middle of them, 6.75. That goes in our table. We'll put it into the equation, 6.75 cubed Minus 6.75 minus 300 is that. 0.796875. In other words, it's too high. So remember what I said last time? If the number in the middle is too high, then we just go down, and the answer is 6.7. Okay, and what would we write? Just that. Okay, let's have a go at one last one to finish things off. A solution to the equation x cubed plus x equals 82 lies between 4 and 5. Okay, let's try 4.5. And remember, we're trying to get 82 here, because it says that in the equation in the question. No? So 4.5 cubed plus 4.5, 95.625, too high. So we've got to reduce our x. No big reductions, no crazy jumping or anything, just 4.4, and that gives us another number that's too high. Okay, 4.3, still too high. Close, but still high. So let's try 4.2. Now 4.2 gives us an answer that's too low. So good, we've got to where we want to be. We've got 4.3 and 4.2. One's high, one's low. Let's get our little graphic up there then. So we said 4.2 was too low, 4.3 was too high. So we know our answer is in between that low and that high. So we try the number halfway between them. 4.25. Let's plug that into the calculator. 4.25. Then we do x cubed plus 4.25 is that. And that is below 82, so it's too low. So remember what I said? If the number in the middle is too low, we go up. If it's too high, we go down. So the number in the middle this time is too low, so we go up to that one. 4.3 to 1 decimal place. And there's our answer. And then what would you write? That's what you would write in the exam. You'd fill the table in and get your final answer. So it's a little bit tricky, that. You might need to go back over and have another little look at that. Good luck. If you're fine with it, then that's good. Go on to video 2, which will take you through the exercise. So it's bye for now, and I'll speak to you on the second video.